Welcome, ladies and gentlemen. It's Mr. Los. The purpose of this video is to provide a very quick review of dealing with scientific notation, how to turn numbers into scientific notation and back out of them again. If you need anything more in-depth, I'd suggest there's a huge variety of other videos that go into a little bit more depth here. But basically, the purpose of scientific notation is to write very small or very large numbers in a slightly easier way. Like, suppose we have this number, 4,500,000. What we do is, in scientific notation, you must write the first number. It has to be greater than 1, but less than 10. So I can keep the 4 and the 5 here that are at the start. And notice that I'm going to have to count how many times I'm going to have to move the decimal to get to this number that I have here. So the decimal is there right now, 4.5. So that's 1, 2, 3, 4, 5, 6. And I'm moving the decimal to the right. That's going to be a positive power of 10. So that would look like 4.5 times 10 to the 6th, positive 6. If I have another example here, so let's say 635, that number right there, 635 million. So here I have 3 digits that aren't 0. I'm going to keep all 3 of those. I'm going to put a decimal right there. That's 6.35. And then I have to count how many times I have to move the decimal. 1, 2, 3, 4, 5, 6, 7, 8. So it's to the right. So that's a positive 8. So it's 6.35 times 10 to the 8th. And that's basically it. That's how we go from large numbers to scientific notation. And again, remember, this number here, to be in proper scientific notation, has to be bigger than 1, but less than 10. I guess it could be exactly 1. If we have small numbers, like let's say 0.00127, again, I need to write a number that's 1 or greater, but less than 10. So I'm going to keep these numbers here, and I'm going to write 1.27. This time I have to move the decimal in this direction to get back to my starting point. So since the decimal is right here in 1.27, I'm going to go 1, 2, 3. But since I'm moving to the left this time, I need to use a negative 3. And then these two numbers are equivalent. Another example, let's say 0.000002870. Now, another issue that can come up here is, if you remember your scientific notation, it turns out that, or rather your significant figures, I mean, all 4 of these digits are significant. So one thing that's true about scientific notation is the numbers in this part are your significant digits. So in this case, I should actually I should write it like this, 2.870, and I'm keeping that 0 because that is a significant digit, and I wouldn't want to drop it. Otherwise, I'd be losing a significant figure from my number. But there'll be another video about significant figures if you need some help with that. But anyway, to get the decimal back to where we began, we go 1, 2, 3, 4, 5, 6, but I'm moving to the left. So therefore, my exponent needs to be negative, so it's 2.780 times 10 to the negative 6th. And there you have it. There's the basics of converting from large numbers to scientific notation and small numbers to scientific notation. Now, suppose you have the number in scientific notation already and you want to convert it out. So let's see, 3.36 times 10 to the 6th. We want to pay attention to whether this number is positive or negative. It is positive, so that means moving the decimal 6 spots to the right. So 1, 2, so I've moved it 2 so far. I'm going to have to move it 4 more times, which means I have to add 4 more zeros there. Now, I'm not going to put a decimal on the end because that would make all of these numbers significant. We only want a 3 significant figure number to match up with my 3 significant figures in this beginning number. So the way I have it there is just perfect. You can put in the commas if you want. So 3.36 times 10 to the negative 6 is the equivalent to that number. If you have, let's say, 4.2 times 10 to the negative 2. In this case, the exponent is negative here, so I'm going to move the decimal to the left, and I'm going to move it 2 spots. So I have 4.2. So move the decimal once, twice, put in a 0 here to fill in that extra gap. 2 significant figures in my scientific notation, 2 significant figures in my number here, so everything's good. And there you have it. There is your quick review of converting numbers to and from scientific notation. There'll be a little bit of practice here for you, and you should be good to go. Thank you, and have a good